Hello, so we're working on confidence intervals. This time it's a confidence interval for a proportion. And we're told that in 1983, 87% of 19-year-olds had driver's licenses. We'll assume they took a sample to do that, a survey to do that. 25 years later, that percentage has dropped to 75%, according to another research study. Suppose that these results were based on a random sample of 1,200 19-year-olds in both years, 1983 and 2008. We're asked to calculate the margin of error and the interval estimate for a 95% confidence interval. So I'm going to do this two different ways. I'm going to do it, or at least set it up, the manual way, and then we'll show the use of the statistical toolkit in order to solve this problem. Now you can see here I have all of the answers because I've been working on this for a while. But I'm going to show you how each one of these answers was derived using the two different methods. So in looking at the setup of this problem, we were told that the proportion in 1983 was 0.87. The proportion in 2008 was 0.75. And the sample size in both cases was 1,200. The formula for the confidence interval of the proportion is P plus or minus Z sub alpha over 2, which is the critical Z value, and then multiplied by critical Z values multiplied by the square root of the quantity P times 1 minus P over N. In this case, the alpha is 1 minus the confidence coefficient. For a 95% confidence interval, the confidence coefficient is 0.95, which gives us an alpha of 0.05. We want alpha over 2, 0.05 over 2 is equal to 0.025. So we're interested in the Z value such that the area under the curve in the upper and lower tail of the normal probability curve would be 0.025. If you look that up in your table, you'll see that that Z value is 1.96, and we use both the plus and the negative value of that. To show you where I found that, if you were actually looking at a cumulative probability for the standard normal distribution, in other words, the Z table, we're looking for an area under the curve in that lower tail of 0.025, which is right here. That corresponds to, in this case, a negative 1.96. We're going to use both the plus and the minus value in our calculation. So our critical Z value is simply 1.96. Putting that into the formula for the margin of error, and again, what you should remember is that the critical Z value multiplied by this element in the square root is the margin of error. The element in the square root by itself is the standard error. But when you multiply the standard error by the critical Z value, that gives you the margin of error. So this is our margin of error formula. Using the 0.87, it gives us a margin of error of 0.0190. If we add and subtract that to the 0.87 for 1983, we get 0.8510 and 0.8890. So those are the answers for the first part of the problem. Using the same process on the second part of the problem, the critical z-value is the same. What changes is the point estimate of the proportion. In this case, for 2008, we dropped down to an estimate of 0.75 in terms of the proportion of 19-year-olds who have driver's license. That gives us a margin of error of 0.0245. Adding and subtracting that to the 0.75 gives us the 0.7255 to 0.7745. So now if you open up your statistical toolkit, again, search for the tab. What we're looking for is the confidence interval of the proportion, which happens to be here. Click OK. And this is the tool that we can use. Now, I've already entered in some of the information. I've entered in the sample size. And actually, if we were given data for the number of responses that fit our interest, in other words, if they told us that 900 of the 19-year-olds had driver's licenses, that would give us the 0.75 for 2008. They didn't actually give us the count for the responses. And the way I've set this tool up is there's actually a comment here that says if you know that number of units in that you're interested in, you can enter it here. But if you don't know it, and you're given the sample proportion as we were in our problem, simply put a 0 here, and then put the actual sample proportion that you were given in this blue cell off to the right. It will then use that sample proportion that you entered to calculate your values. The margin of error that we're interested in for this first part A is 0.0190 to 4 decimal places, and the lower limit 0.8510, the upper limit 0.8890, which is what we found before. Likewise, for the second part, I've been playing around with it, so I happen to know that if I were given 1044, that would actually equal the 0.87. I'll prove that by making that 0, and it calculates the sample proportion, if I actually knew that number, which I don't. If you double click on this cell, what you'll see is that there's an if statement built in. If E5 is 0, then it uses the value in E6. Otherwise, it uses E5 and E3 to calculate the sample proportion. But again, we were not told how many people had driver's license. We were given the proportion of 0.75 for 2008. So that gives us the 0.7255, the 0.7745 as the confidence interval, as the 95% confidence interval. Of course, in order to do that, we have to make sure that we put the confidence coefficient of 0.95 in E8. If you had a different confidence interval that you were interested in, such as 99 or 85, the ones most often used, or 90%, then you would change this decimal here. So again, going back, we see that all the values that we calculated by both methods are correct. And part C, is the margin of error the same in parts A and B? No, it's not. Why isn't it the same? Because we have different point estimates for the population proportion. In 1983, we had an estimate of 0.87 for 87%. In 2008, it was 0.75. And since those proportions are used in the calculation of the standard error and also the margin of error, it's going to give us a different margin of error value.